Good morning, guys. Happy Monday. Welcome to today's lesson, May 11th, factoring using the AC method, day 2. All right, let's first take a look at the do now. We have a multiplication question, a binomial times a binomial, so we need to set up box method, right, a 2 by 2 box because it's two binomials. We have m plus 1 and 7m minus 1. M times 7m is 7m squared. M times negative 1 is negative m, which is negative 1m. 1 times 7m is 7m, and 1 times negative 1 is negative 1. Remember, now we have our like terms, the two m values. So 7m squared minus 1m plus 7m minus 1. Combine those like terms. Negative 1m plus 7m gives you 6m. So we have 7m squared plus that 6m minus 1. And you're done. So we're taking another look at the AC method, guys. We talked about that on Friday, all the steps that go into it, sort of like a special trick to complete these problems a lot quicker and really easier than you've learned about in Algebra 1. So this is a great tool, seriously, a great tool to take into your Algebra 2 studies. This and long division are probably the two most important lessons you can take away from this little Algebra 2 prep period. So AC factoring, here's your steps. We're not going to read through every single one. It's better for us to talk it out as we go. But these are steps that you can refer to as you try a couple on your own, which at any point, you can try these on your own, guys. You pause the video, try it out, see how you did. All right, but let's look at a couple first. All right, so first, we check for GCF no matter what. All right, no matter what type of factoring, anytime a question tells you to factor, we look at GCF first. Right now, there is no GCF. It's a trinomial, and the A value, right, the A value is 7, which is obviously greater than 1. So that's how you know we're using AC factoring, not AM. If the value was 1 exactly for A, we would use AM. But since A is 7, which is greater than 1, we use AC. Let's keep in mind our B value is equal to 6, and our C value is equal to negative 1. So with this AC method, we multiply A times C, which is 7 times negative 1, which is negative 7. So now what we need is something that two values, right, two numbers that are going to multiply, that little x today is going to be multiplication, that multiply to negative 7 and add to the B value, right? The B value is equal to 6. So what are the two numbers, the two integers really, that are going to multiply to negative 7 and add to 6? Think about those values. All right, those two values would be 7 and negative 1. This right here, guys, is the hardest part, figuring out what those two values are. Now, if you follow the steps throughout the rest, you're going to be good to go. All right, so because 7 times negative 1 is negative 7. 7 plus negative 1 is 6, so 7 and negative 1. So now we write two binomials, open up two sets of parentheses, and instead of writing, you can write these two numbers now, so it would be plus 7, positive 7, and negative 1. And instead of writing m in there like you would with the AM method, we write the value 7m in front. Okay. Now, we could have written, if this value for A, right, the 7 value, if that was 2, it would be 2m in there. If it was 3, we would write 3m. If it was 5, we'd write 5m in there. So this is now 7m. Okay. Now, typically one of these, we don't just leave it here, one of these binomials, we can factor something out. All right, and it happens to be the first one. There is something that we could divide both of those terms by to sort of break it down a little bit more. And this is where the trick kind of comes into this type of factoring. All right, so you can divide both of those by 7, because 7 goes into 7m and 7. So this turns to m plus 1. and then you keep the second binomial, 7m minus 1, and you're done. This is so much less work than the way you learned it initially, like in Algebra 1, but it's more thinking. All right, it's more just like breaking down the problem. All right, you have to really think about it, but I think you'll find this way easier than you learned in prior years or whatever. All right, so I also want you to see how you could check your answer. You might be thinking to yourself like, all right, I did it. Did I do it right? All right, I don't have anyone to guide me. All right, you can use the box method. All right, box method, binomial times binomial, and see what you get. And that's why the do now today was do m plus 1 times 7m minus 1. And you see we got 7m squared plus 6m minus 1. That was the problem, guys. Okay, that's what we ended up with. So you can do the box method. You do the box method, you see that you get that exactly. So it's a great way to check your answer. All right. Next. All right, check for GCF. GCF, no go. It's 3 terms. It's a trinomial. Is it AM or is it AC? It's AC because the value in front of k squared, is bigger than 1, so it's AC. So A times C, which is 3 times 7 is 21. So we need values that are going to multiply to 21 and add to the B value, which is negative 10. So all the values A, B, and C get incorporated in some way at the beginning. All right, it's A times C, and then we need to factor in that whatever we get, it has to add to the B value. So A, B, and C are all involved. So what multiplies to 21 and adds to negative 10? So if it's going to add to a negative, guys, these values have to be negative, and we're multiplying and ending up with a positive, so it has to be a negative times a negative, right? Negative times a negative gives you a positive. All right, so these two values would be negative 7 and negative 3. Right, because you multiply those, you get 21. You add them, you get negative 10. So now your two binomials, we can write them in. We have minus 7 and minus 3. Now we're not going to write k, we're going to write 3k because the a value is 3. So 3k the first binomial you cannot break down. 3k minus 7, can't break it down any further. 3k minus 3, you can break down. Divide both of those by 3. So we have 3k minus 7, and we have k minus 1. And you're done. Now keep in mind why this is really like not a full-blown like lesson that's taught in every math class, and why it's not like, I don't know, something that you would see a lot more often than normal, is because it's kind of a trick. Where the trick comes in is that you're dividing this 3, but with true GCF factoring, if you're going to divide out a 3 or something like that, you have to throw the 3 in front of everything. All right, so we don't do that in the AC method, in this sort of a trick of a way to do this. Okay, we're kind of beating the system a little bit, which is great, all right, because this does make your life a lot easier. Please take this into your Algebra 2 class. All right, but you're done. How could you check your answer? Box method. How could you quickly check your answer on something like a multiple choice test? 3k times k gives you 3k squared, and negative 7 times negative 1 does give you 7. So that's a quick way to check. Do the first terms, multiply them. Do the last terms, multiply them, and at least make sure that works out. All right, next. So you go through your thought process of, is there a GCF? There's not a GCF. So is it a trinomial? Is it a binomial? It's a trinomial. A is bigger than 1. It's AC. All right. AC is equal to 5 times 8, which is 40. So they need to multiply to 40 and add to the B value, negative 14. So what are those two values? What do you think? What multiplies to 40 and adds to negative 14? Once again, these two values have to be a negative and a negative because it's multiplying to a positive and it's also adding to a negative. So they have to be two negative numbers. It's -4 and -10. Multiply them out real quick. Yep, that's 40. Add them, that is -14. So you have your two binomials, -4 and -10. Now, once again, we're not going to write x in front. We're going to write what in front? Is it 2x, 3x, 4x, 5x, 6x? It should be 5x. It's just the a value in front. Alright, so 5x and 5x. Now, which binomial can you break down? Is it the first one or the second one? It should be the second one. You could divide both of those by 5. So we'll end up with 5x minus 4, the first binomial as is, and then x minus 2. Also remember, I told you, look back if you still have like your notebooks and OneNote from Algebra 1. Look back at how you learned AC factoring. Alright, it's going to seem very, very complicated compared to this. Alright, please remember you can, I feel like I keep repeating myself, which that's because I am. You can pause the video at any time and try these on your own. You don't have to watch me do them, but I am going to go through them all. Alright, so AC is equal to 2 times -5 now. Alright, has our AC value been negative up to this point? This first one, yes. So 7 times -1. Alright, it's negative again here because it's 2 times -5, not 2 times +5. Be careful. Alright, so 2 times -5 is -10. So it needs to multiply to -10, these two values, and it has to add to the b value, which is -3. So guys, if it's multiplying to a negative, the signs have to be different. Alright, for the two numbers. One has to be positive, one has to be negative. Alright, so what are the two values? This would be a perfect time to pause the video and think about that to yourself. But it would be -5 and 2. Right, multiply them, they give you -10. Add them, they do give you -3. Two binomials, set it up. So we have -5 and +2. We're not going to write x in that slot like we would do for AM factoring. We're going to write 2x. And for one of them, we can divide out a GCF, which would be here. We can divide both of those by 2. So it's 2x minus 5 and x plus 1. In this type of GCF, like at the end here, remember it's not full-blown GCF like you've learned before. Okay, it's just saying it's always going to be a number when you're dividing it out. Okay, it's essentially saying what's the biggest number that goes into both those terms. It's not going to be like a divide by x or divide by x to the third or nothing like that. It's just divide one of them, one of the binomials, divide both the terms by a number, and it's the biggest number that goes in. Alright, 17. This is actually one earlier when I was, sort of making an answer key for this. I made a silly mistake because if you're careless, it's very easy to make a silly mistake. Alright, so AC. Alright, 5 times 12. What is 5 times 12? 60. So we need factors that multiply to 60 and add to 19. So what I did initially, I was just working very, very quick. I was like, all right, 5 times 12. Yep, that adds to 19. No, it doesn't. 5 and 12 adds to 17. So be careful. So what are the two values that multiply to 60 and add to 19 positive? So positive values all around. It would be 15 and 4. Alright, so we have our two binomials, plus 15 and plus 4, and we write 5p in front. 5p, 5p. Which one can we divide out? A number. It's the first one. What could we divide both of those by? It would be 5. So we end up with p plus 3 and 5p plus 4. Alright, next one. AC is negative 24. So they need to multiply these values, multiply to negative 24, and add to the B value, which is 10. What are those two values? They're multiplying to a negative, so they have to be different signs. It is 12 and negative 2. So open them up, those two binomials, positive 12, negative 2. We're not going to write n in front, we're going to write 3n. 3n, 3n. The first one has a GCF you could divide out. Divide both of these by 3. So you end up with n plus 4 and 3n minus 2. And one more, a challenge question. You run through your steps, right? A GCF, no GCF. Is it a binomial that might have like dots or something like that? Nope. It's a trinomial. Is it AM or is it AC? It's AC because the A value is bigger than 1. So AC is equal to 6 times 12, which is 72. So they need to multiply to 72 and add to the B value negative 17. So if it's multiplying to a positive, it's either a positive times a positive or a negative times a negative. And in this case, it's going to be a negative times a negative because it has to add to a negative. So what are those two values? They multiply to 72 and add to negative 17. It would be negative 8 and negative 9. So you write your parentheses for your two binomials. We have a negative 8 and a negative 9. And we're going to put a 6r in front. So nothing really overly complicated yet. Maybe finding the factors of negative 8 and negative 9. Maybe not. The tricky part about this one is both of them divide out in terms of having a GCF. Alright, it could be both. Typically it's just one. Alright, I would say 95% of the time you're just going to divide out one of the binomials here, but in this case you can divide them both out. So what can you divide both of these by? What number? These would be 2. Alright, but also the next one, what can we divide those by? 6r and negative 9 should be 3 and 3. So a little tricky there. We end up the first one, 3r minus 4. And the next one, we end up with 2r minus 3. Alright. Now that's it. Once again, this lesson is so valuable, really something that students struggle with. And then they sort of see this trick of how to do it, and they're like, alright, actually this isn't that bad. I really, really encourage you to bring this to your Algebra 2 class next year. This is great. This and long division, once again, I think are the most important lessons I can show you in your prep, you know, to just making sure you have all those basic skills down pat. Alright, factoring is involved in so much in Algebra 2, it really is. Alright, guys, that's it. Your Delta Math is going to be posted very, very shortly, so you can get a head start on that. It'll be due Thursday, as always. You have a wonderful rest of your day. Let me know if you have questions, and remind, and I'll see you mañana.